Right, hello my favourite statistics people. Today we're looking at the binomial distribution and in particular its mean and its variance. So first things first is the formulas for the mean and variance are as follows. If our distribution is binomial with number of trials n and probability p, the mean is the number of trials times probability. And our variance is number of trials times the probability times Q. And let's not forget that Q is simply the chance of failure, which is 1 minus P. So to write that down, and let's look at a question involving the mean and the variance. This is a lot of writing. So take a moment, pause it, and write this down. Right, the first thing we need to check, because let's face it, if you are in an exam, first of all, they won't tell you it's binomial or Poisson or whatever. Or if you're in a job and some guy, your boss says, "Hey Bruce, give me a report." He's not going to say, "Oh, and by the way, use a binomial distribution," and be like, "Do the report, give it to me, and tell me afterwards." So you need to recognize what makes this binomial. So here's your boss. So for these four conditions in the question. So an examiner is trying to design a multiple choice test. Now multiple choice, that tells you that number 2 can be a success or a failure. Okay, because if it's like an algebra question where there's multiple marks, or it's a history question, there's some grey areas there. Is this a straight, either you're right or you're wrong? So each trial can be a success or a failure. For students answering the test at random. So at random kind of plays into the fact that trials are independent. So there's random, there's no guesswork, there's nothing affecting it. It's not like, oh, I answered A the first time, I answered B the next time. It's literally randomly answering. Okay? Now, the examiner requires that the mean score should be 20. That's useful to remember for later on. Let's just underline this. The mean score is 20. Remember, our mean is going to be NP. And the standard deviation of at least 4. So remember, the variance is our formula. Okay, this is our standard deviation. And the standard deviation is the square root of the variance. So, assuming that each question has the same number of possible answers. Right, that should ring some bells. The same number of possible answers. So every question has the same chance of success or a failure. Okay, every question, there might be 4 solutions with 1 right answer, so 25% chance of being correct, okay? Every question has the same chance of success or failure. Find how many questions and how many possible answers each question should have. Number of how many questions will be our n, and the possible answers is our probability. The number of possible answers should be as few as possible. So there's our n, fixed number of trials, a limit to our questions, success or failure, we've done that, independent, it's all random, and success is constant. Now, bye-bye sir, see you later. Now, why might someone ask this? Well, if you're an examiner and do multiple choice tests, you want the pass mark to be high enough to ensure people can't just guess an answer and pass anyway. Okay? So let's define our distribution. Well, we're saying it's binomial. So x is binomial, n and p. We don't know n or p just yet, but x is a number of questions that a student answers correctly. if they're answering at random. Okay, n is the number of questions, and p is going to be the probability of randomly getting it correct. Getting it correct. Okay, so here's our facts. Let's look at how to find out our solutions. If you want, you're more than welcome to pause it and give it a go yourself. So, the things we know. We know that the mean should be 20, so exactly 20. So our mean should be 20, and we know that the mean is the number of trials times the probability is 20. We're also told the standard deviation of at least 4. Now remember that standard deviation is the square root of the variance. So if standard deviation is 4, then the variance is going to be 16. So the variance is going to be at least 16. So bigger than or equal to 16. So our variance is NPQ, so NPQ is bigger than or equal to 16. Check here, you've got NP there, NP there. So you can substitute this into that inequality. So you substitute NP equals 20 into, let's label these 1 and 2. So we're going to get 20 Q is bigger than or equal to 16. So Q is bigger than or equal to, divide by 20 on both sides. That is a 20, honestly. 0.8. Now remember, of course, that Q is in fact the chance of failure. So chance of success, so that is in fact Q is 1 minus P. So 1 minus P is bigger than or equal to 0.8. I'm going to subtract 1 from both sides. So negative P is bigger than or equal to negative 0.2. With an inequality, we don't want negatives, because you don't want a probability is negative, that's weird. We're going to times both sides by negative 1. Okay, now remember, when you multiply an inequality or divide by a negative, it is going to reverse our inequality sign. So probability of success needs to be 0.2 or less. Okay, if it is 0.2, that is a 20% chance of success by randomly guessing, which must mean there were 5 questions. Okay, remember they said looking for the number of possible answers should be as few as possible. If we increase this to 6 or 7, 8, 9, 10 questions, this is going to go down and still satisfy this part of it, but with as few answers as possible. As soon as it goes to 4 questions, this becomes 0.25, which is too large for inequality. So we can be quite safely and happy that we have 5 questions, a 0.2 chance of success. In which case, going back to equation 1, which was NP equals 20, we now know that P is 0.2. So 0.2 N equals, wait, there we go, 20, divide by 0.2, and the number of questions is going to be 100. So, for our professor here, our examiner, she'll need 100 questions. Each question needs 5 possible answers to ensure that just by randomly guessing, your mean score is 20 with a variance, standard deviation of about 4. So maybe if you're trying to set a basic pass mark, you might choose 25, 30 to ensure that you know that student must have studied something to at least get some questions right, rather than just randomly guessing. Right, that's a quick overview of the mean and standard deviation and the variance for the binomial distribution and why you might need to use it.